Okay, let's take a look at a couple of examples of simplifying complex fractions. Remember, of course, a complex fraction is just a fraction in which the numerator or denominator, or both, have fractions inside of them. So, for example, number 1, 3 minus 2 over x, all of that over 1 over x plus 1 minus 1 over x. Of course, the presence of this 2 over x in the numerator, or the presence of this fraction or this fraction in the denominator, makes it a complex fraction. Okay, so there's a couple of different ways we could proceed, and let's look at all of them. One way, a very direct way, is to go ahead and do the two subtractions first. Okay, we have a subtraction of two rational expressions up top. We would need to get common denominators to accomplish that subtraction. It looks like the only thing the first rational expression, 3, it's a trivial one, is missing from its understood denominator of 1 would be just this x. So I could rewrite that as 3x over x minus the 2 over x. It's not missing anything. On the bottom, similarly, I could say, well, look, this denominator has x plus 1. It's in factored form. It's missing this x, though. Let's put one of those x's on there. So we have x times x plus 1. Of course, if we put it in the denominator, we'll have to put it in the numerator as well. So we've multiplied by a well-chosen value of 1, x over x. Likewise, over here, we're missing the entire x plus 1. So I could say, well, okay, that's going to be x times an x plus 1. But I had to, again, multiply by not only x plus 1 in the denominator, but also x plus 1 in the numerator. And times an understood 1 still just gives me x plus 1. Okay, so I'm setting this up to do the subtraction both in the top and the bottom. We have common denominators now, so we can put them together. 3x minus 2 over x. The subtraction has been done in the top. Down here we have common denominators, so I can do the subtraction. X minus the quantity x plus 1. Be careful there, that negative is going to distribute through both of those over the common denominator of x times x plus 1. Okay, let's clean it up just a wee bit more. Let's go ahead and distribute that and collect x minus x. That drops off, and then we're left with a negative 1 right there. Okay, now why is that helpful to go ahead and do the subtraction here and do the subtraction here? Look what we have. We have a fraction over a fraction. If you have a over b over c over d, remember that's the exact same thing as the fraction a over b divided by the fraction c over d. That's the exact same thing as a over b times the reciprocal of c over d, hence d over c. And so upon turning that into a multiplication problem, things become very, very easy. You have AD over BC. That's essentially what we've done here. Okay, so we can rewrite this as 3x minus 2 over x times the reciprocal of this guy. So that's an x times an x plus 1 over a negative 1. Okay, so all we're left with here is the product of two rational expressions, which we know is easy. All we have to do is make sure everything is factored and cancel what's common across numerators and denominators. And the only thing common here are the two x's. Okay, so we get this times this over negative 1. Of course, dividing by negative 1 is just like multiplying by negative 1. So I can tighten things up even further there. Let's see, that's going to be 3x minus 2 times x plus 1. I'll just put a little negative there in the front. If you wanted to expand it out, you could. Let's see what we got here. 3x squared times another negative. We've got an inner product of negative 2x, an outer product of plus 3x. That's a single x net. And then when we make it negative, we get negative x. And last but not least, we have a product of two last terms of negative 2 times this negative makes that positive 2. Okay, so that actually tightened up quite a lot. Okay. Now, there is another way to do it, like I said. And oftentimes, it's a little faster. Starting again with this. Another way we could proceed is to say, well, look, these little denominators here of x and x plus 1, I really wish we didn't have those. right? Then it wouldn't be a complex fraction, and maybe the life would be a lot easier. I could get rid of that little denominator of x in the top if I multiply this whole thing by an x, right? X times 2 over x's, the x would cancel. And x times 3x, well, I get something else. I could get rid of these pesky little x plus 1 denominator and this pesky little x denominator down here in the big denominator if I multiplied by the product of x and x plus 1, right? We have just the right factors we need to get these things to cancel off. The x plus 1 here would cancel with the x plus 1 here, the x would cancel with the x here, and everything would be great. I would love to be able to multiply the denominator by this and the numerator by this. But we can only really multiply by a well-chosen value of 1 if we don't want to change things. So look, put another x plus 1 here, and now we've got a well-chosen value of 1 right there. And we still have all the factors we need to get these little denominators to cancel off. Okay? So you multiply by what you need here to get the little denominators to cancel off. Now when you do that, distribute this to each term of that binomial. There's no denominator under the 3 except for an understood 1, so nothing's going to cancel there. We're left with 3 times x plus 1. Minus, here, 2 over x times this mess, the x's cancel, and you're left with minus 2 times x plus 1. All of that over. Down here, distribute this to this. The x plus 1 is a common factor. It cancels off. You're left with just x. And then this distributed to the 1 over x terms. The x's cancel off, and you're left with a minus x plus 1. Look how quickly we get to, let's see, this step here. This is going to be 3x squared plus 3x minus 2x minus 2, just expanding that out, x minus x, the x's drop off, and we're left with a distributed negative here on this 1, so negative 1. Collect like terms. You get a 3x minus 2x. Divided by negative 1, which just changes the signs. And we are right back to the answer in decidedly fewer steps. There's only like 3 steps there. 1, 2, 3, 4, 5, 6 steps there. Okay? So, I like this method a lot. I'll use it a lot. Let's look at another example. Example number 2. 1 over a plus 1 over b, all of that over a minus b over ab. Okay, so we got another complex fraction here. It'd be great if we didn't have these little denominators of a and b and ab. That's what's making it a complex fraction. Let's see, what could we multiply this whole numerator by to clear out these two denominators of a and b? Certainly ab would work, right? A to clear this one, b to clear that one. What about the bottom? What could we multiply all of that by? Here again, wouldn't ab work? No massaging to be done here. This already is a well-chosen value of 1. If I multiply by ab over ab, all these little denominators should go away. So let's see, ab times 1 over a, distributing that, the a's cancel, you're left with b. ab times 1 over b, the b's cancel, you're left with an a. Down below, ab times this guy here, the ab's cancel, you're left with a minus b. Maybe we write it a little bit more aesthetically pleasing, or in a more aesthetically pleasing way by making that alphabetical. But you know what? We're done. Nice and fast. Okay? All right, so that was a couple examples of simplifying complex fractions.